In this video, we'll talk about solving logarithmic equations, and this will be a part 2. In this case, we'll use exponential equations in order to solve some logarithmic ones. So this is kind of where the two meet. Okay, so let's take a look at a simpler example, and we can kind of use this as a governing thought for more complicated ones. So I have log base 2 of x is equal to 4. Now, I don't know how to undo a logarithm, but what we can do is we can convert this into an exponential. So, keeping in mind that our little example here, 2 cubed equals 8 if and only if log base 2 of 8 is equal to 3. So we're just going to rewrite this a little bit. So we'll have 2 to the 4th is equal to x. And just like that, we have a number. X is 16. And I'm done here. So that's kind of our governing idea. Sometimes when you run down a logarithm to the point where you have a log of something is equal to a number, you can convert it to an exponential and your work is pretty much done for you. So now that we have that thought in mind, let's look at another example. So this one is a lot more complex. However, the first thing we're going to try and do is we're going to isolate this logarithmic expression. So we'll treat this just like we would any other variable if we're just doing some algebra. So the first thing we're going to do is we're going to subtract 7 from both sides. So we'll have 5 times log base 3 of x plus 1 is equal to 5. Now, there's a couple of ways we can go from here. We can try and bring the 5 in as an exponent. However, since we have this binomial expression, I think it's going to be better off if we just divide up by the 5. Instead of trying to expand out x plus 1 to the 5th power, let's just divide by 5. So I have log base 3 of x plus 1 is equal to 1. Now at this point, we have log of a thing is equal to a number. So we're going to convert. So we'll have 3 to the 1st power, that's where the 1 comes from, is equal to x plus 1. And we know that 3 to the 1st power is 3. Then we subtract 1. X has to be 2. So our solution is 2, and then we just have to make sure that we can plug it in to make sure it works. So if we plug in 2 plus 1, it's 3. 3 is positive. Okay, we can use that in our logarithm. Now, if it turned out to be 0 or a negative, we'd have to say we can't use that. That's an extraneous solution. But since this one works, it checks out. Our solution is x equals 2.